My name's Kevin Rakin. I've been a Cure board member for many years on the executive committee, active in Connecticut in life sciences, biotech, medical devices, both as an entrepreneur, a business leader, and also as an investor. It's interesting because over the last 25 years it's become kind of more cool, if you will, to launch startups and be involved in startups. But, it's fun to be involved in startups. It's high energy and all that. I think what's tough about startups is, you're an optimist, otherwise you wouldn't be an entrepreneur, and yet in the real world we hit all kinds of problems. So I think the biggest thing is you can't let any one problem overwhelm you. You just got to keep pushing through, believing in your vision, and yet executing on the details. How do you take fascinating technology, interesting science, capital, and business principles and put that all together and actually create something that can be sustainable? It's one thing to get a business plan together, it's another to raise initial capital, but how do you actually build a long-term sustainable business and deal with all the challenges that you have to deal with in life sciences? So, probably if I knew what I know now, I might never have got started, but in 1990 when I got started, it was just the same kind of thing of, wow, I'm talking to these interesting Yale professors, this is fascinating science, the genomics world was just starting, and so, you kind of have to take a leap of faith and take a plunge and get started. Back then, Yale literally had 2 people in its tech transfer office. No one was talking startups in New Haven, or very, very few people, whereas, as I was saying, today it's a mainstream thing. People come out of the MBA school and say, I want to do a startup. On the science side, unfortunately he's passed away, but Professor Frank Ruddle was just an amazing man for having done some of the early mouse genetics. I think he was, I'm going to get the year wrong, but sometime in the 70s he was on the front page of the New York Times when all of this stuff started saying, wow, we're doing genetic changes in mice, imagine what that'll do in the future. And Frank had a great vision for what genomics would bring, the Human Genome Project would bring, and yet what I always respected about him is he would explain the science very patiently, but understood that every area of science and business and law or whatever needs experts, and so never tried to say, here's the business decision you make, drew a line between the science and the business. And he was very passionate about Yale and believing that one of the futures for Yale and New Haven was commercializing biotechnology. And so he was extremely thoughtful man and helpful man with decades of experience as an older person. And then the other person who's been a great mentor to me is a venture capitalist called Seth Rudnick, who has also been around a long time, did some of the first biotech drug commercialization. He's an MD by training, but did some of the first drug commercialization at Biogen and Schering-Plough. In the early days of biotech drugs, again, this perspective of having been in the industry since the 80s, and also had a very good perspective of the big picture of drug development, the challenges of building a business out of it, and how a lot of different people, biotech, I know it's a trite saying that it takes a village to build a company, but in biotech that is especially true because you just can't do it on your own. There's so many, your patent law alone is so complex. FDA trials are so complex. Getting the science to become, industrialized, if you will, is so complex. And then dealing with the finance aspects is incredibly complex. I think you can learn whatever your core educational discipline is, whatever it is, whether it's a science but I think when it comes to kind of entrepreneurship and starting a business, I don't think I would have done anything differently because I don't think you can plan for it, I guess is the point I'm trying to make. I think you've got to take that leap of faith and jump into it. But what you can't be scared of is failure and mistakes. And one thing I like to always say is you just got to deal with reality. So the challenge of being an entrepreneur, I think, is you have a vision and you hope for creating something huge. But if you don't deal with reality every step of the way, it can spiral out of control real quick. And then I see people in denial, and it can get ugly if it spirals out of control. So, and I don't think I could have planned any other way. So I think Connecticut, let's start by saying Connecticut can do more. I mean, Connecticut is not where it should be. You know, you go to a San Diego or a Cambridge, Mass., it just blows you away what's going on in life sciences. But what Connecticut has is incredible researchers at Yale and UConn. I mean, truly world-class research, incredible research dollars that have come in there. We have, I believe, a critical mass of, because we're a smaller state, you can actually get your arms around all the people, the capital suppliers. We're close to New York City, where there's more capital than you could ever dream exists in the world. And it goes back to this point I was making, that because getting these early stage businesses off the ground is tough and doesn't always attract the really smart capital, because they know how tough it is and they know how tough it is to get a return on that capital. I think we need to do more in Connecticut for breathing life into these businesses and support them. We do a lot. There's Connecticut Innovations. The state of Connecticut supports that. But we need to do even more if we're going to, because otherwise we're constantly going to fall behind the true centers like Cambridge, Mass., or as I say, you go to San Diego or San Francisco. What I find fascinating about this world is you've got incredibly complex science and incredibly sophisticated finance and business issues. Never mind your regulatory issues, the FDA, patents, and even Medicare and reimbursement, especially in today's healthcare environment. And so the smart, savvy capital guys say, well, why would I have invested at the beginning of something? Why don't I wait till, like in the case of Dermograph, it went through 15 years, $500 million, and then finally we could make a success of it. Now that's an extreme example. Others are successful 5-10 years on. But because the science is, biology is complex, and because what we have in life sciences that we don't have in IT is the FDA and Medicare and a lot of government regulation, the risks and the time from initial conception of a plan and launch of a business to actually getting a product out there are huge, far greater than IT, for instance. So there are a few areas I really think are interesting right now. My main theme for my fund is, and you probably picked up on this while we've been talking about it, is that bring more business discipline to the science. So I find a lot of companies that have gone 3, 4, 5 years, they've developed the science a certain way, they've gone through 10, 20, 30, maybe even more millions of dollars, and the management says, okay, I developed a potential product here, but how do I turn it into a business? And what intrigues me is that it takes a certain skill set to commercialize the science, launch it, get a product that can be getting through the clinic, and then it takes often, especially in today's world, a different skill set to commercialize it. And that's partly compounded by there's such pressures in terms of healthcare reform on costs and on our healthcare spending that the old days you could just launch a product and it would almost sell itself, and that doesn't happen anymore. Reimbursement's tough, the hospital sales process is tough. You literally can get a product approved and then have to go through another 3-year fight to get it reimbursed. So what fascinates me is getting into interesting science, but that needs business kind of operations put around it. And that can be molecular diagnostics, I think, is an interesting area that's still evolving and still growing. I think regenerative medicine, which is what Dermograph was part of, is a fascinating area. The ability of the body to repair and regenerate its own organs is amazing. But again, challenging to pull all the pieces together. And the other area that I still find intriguing is kind of, what are we going to do with the $1,000 sequence? So again, extension of diagnostics, but from the instrument perspective. What are we going to do with being able to measure your genome, and how are we going to do that in practice, and how will physicians use that, and how will the Medicare system reimburse for that? So what does that all mean in terms of true kind of advancements in healthcare and yet new standards of care that physicians may not fully understand how they're going to use it.